Moving on to the theoretical basis, this tool assumes a basic system where any organic fraction that's coming into the soil, for example crop residue or manure or the cover crop residue, all of that is converted into a plant residue equivalent, and that essentially represents the amount of organic matter that relates to the above ground as well as below ground biomass for that particular component. Now this plant residue equivalent gets added to the organic matter that the soil already has. Now this total pool is sort of made of the active fraction, which more relates to fresh organic matter, fresh residue, which decomposes faster, and then the passive fraction, which is slightly slow decomposing fraction. And then over a period of time, both these fractions decompose at different rates, and eventually you get a certain fraction of each of these pools to form the total organic matter. Now these decomposition rates definitely get affected by some of the natural factors as well as some of the management practices that you have in the field, and also there are some losses of organic matter due to soil erosion. Now the SOM calculator takes into consideration some of the management practices, for example the crop rotation, tillage, cover crops, manure and drainage and irrigation, and then it also takes into effect the loss of organic matter due to erosion. Now the typical output of the calculator is the total soil organic matter content. It also gives you the active and passive fraction of the organic matter, and then the carbon sinks and sources. Also it gives you the revenue generated due to residue removal, for example removing the corn residue for bioenergy purposes or any other commercial purposes, and how much of revenue you would get because of that. Some of the additional outputs of this tool are the carbon credits or the CO2 sequestration or loss that you may see because of change in organic matter content of the soil, and then also the change in nutrient status of the soil because of the organic matter content change. This theoretical basis for the tool was developed by Dr. Robert Lucas at the Michigan State University, and he proposed two different equations to describe the decomposition rates of the active fraction and the passive fraction. And as you can see, the green line on this graph relates to the active fraction, and it's an exponential decay function, and then a linear decay function for the passive fraction. You don't have to remember all this to be able to use the model. This is just a more detailed description of the theoretical basis of the model, and the actual tool which is available in its version 2 is the SOM calculator. It's an Excel sheet based tool, and it's compatible with the Microsoft Excel 2007 or any version after that. So this is how the spreadsheet tool looks like. All the input cells are color coded, so that, for example, all the green cells relate to crop. And the good thing about this is that the user does not have to use the spreadsheet to input all the information. There is a data entry form that you can use to input all the information. Now before I show you the data entry form, I want to show you the layout of this Excel spreadsheet. And the first worksheet in this file is a user guide. It has an inbuilt user guide that you can refer to, and that will give you some direction on how to use the tool. Then the main worksheet is just this active sheet that you can see on the screen is the actual organic matter calculator. And then the most important worksheet is a printable report worksheet, and you can use this worksheet as your final product from the tool and simply print it for your records or for taking a closer look. Now moving on, if you go into this data entry form, this is how that looks like. And essentially this data entry form provides you an interface to input all the information into the spreadsheet. The first page of this data entry form has inputs that relate to simulation period, which is essentially for how long you want to simulate, you want to generate the scenario. For example, if you want to look at the organic matter dynamics in your farm starting in 2015 up to 2030, so a 16-year simulation period, you can specify those inputs in here. And then the next frame relates to the crop rotation, for example a corn soybean rotation, that you can specify along with the tillage type and the manure application. Once you're done with the crop rotation, you can go to the next page, which is the page 2, and the first frame on page 2 relates to baseline scenario. It essentially means the initial condition of the farm. For example, what is the organic matter content of the farm in the first year, and so on. And then the second frame relates to the management scenarios, for example tillage and drainage and irrigation and so on. And then you can see on the same page you have a second frame that relates to cover crops, and you can specify a cover crop, specify if you harvested any yield from that cover crop. And then the third frame on the page 2 is it relates to erosion. You can specify the erosion rate from your field in tons per acre per year and that will get saved in the background in the actual spreadsheet. Now once you're done with all these inputs on page 2, you can move to the third page, and third page is the last page where you can specify the residue removal rate if there is any. For example, if you are removing any residue, for example corn residue, after every 2 years in a corn soybean rotation, you can specify that, and then hit the calculate button. And as soon as you click the calculate button, the form takes all the information, populates the worksheet in the background, and then gives you the output in the printable report. And this is how the printable report looks like. It's too small to see any characters on this screen, but in the subsequent videos I'll explain each and every component of this report. But as you can see, it gives you a graphical output to show how the organic matter content changes over time, as well as some of the outputs in terms of numbers, for example change in organic matter content and so on. It also gives you a split between the active and passive fraction of the organic matter content. So this concludes the overview of the interface of the calculator. Now moving on, this is to a hypothetical scenario to demonstrate how sensitive demonstrate the sensitivity of the calculator. And it starts with a base scenario which assumes corn soybean rotation with conventional tillage, and it has a slightly increasing trend starting in 2012 going into 2035. And if you add a management option that's residue removal, it shows that your organic matter content is going to have a decreasing trend, and you might end up somewhere in the range of 2% organic matter content during this time period. If there was any erosion, that further makes the organic matter content worse over a period of time. And now you can also bring in management options that can help you increase or mitigate some of these negative effects. And the first option you can think of is cover crops. If you add a cover crop, you can see the trend you can see an increasing trend in the organic matter content, and you can further enhance that by using something like a conservation tillage or a no-till system. So this shows the relative sensitivity of the tool for a hypothetical scenario, and also shows you that you can use this tool this way to compare different scenarios. We did test the tool for its accuracy, and this is just one example. This is data from the Morrow plots, the long-term experimental plots that we have in Illinois, and this was data for continuous corn. The data was split between two time periods. This is 1913 to 55 and 1955 to 1990, after the introduction of corn hybrids. And the dots here represent the measured values of organic matter content, and the solid blue line shows the simulated values by the calculator. So you can see there is a very close agreement between the measured and simulated values by the calculator. So it shows the accuracy of the calculator. Again, additional studies on the same graph, and you can see that the calculator, the actual that is measured and predicted values are very in a close agreement with each other. And these are studies based in Michigan, Illinois, and Ohio. Moving on, this where to get it. You can download or you can request for the calculator using one of these links, and I will show you how. You click on the go.osu.edu/SOM calculator, or you can simply go to the OSU South Center's website, and when you click on this link, it takes you to the soil, water and bioenergy programs website web page, which has hosted